In this first example, we're given the rate equation for the reaction of propanone with iodine. So it's a substitution reaction, and you can see that it's catalyzed by H+. And in the first case, we've just got to work out the overall order. So that's pretty straightforward. All you have to do is simply look at the order with respect to each reactant. So order 1 for propanone and order 1 for H+, and just add them together. So it'll be 1 plus 1 equals 2. Now on to the main bit. So when the initial concentrations of the reactants were shown in the table below, the initial rate was 1.24 times 10 to the negative 4. Use the data to calculate the value for K and determine the units. So the first thing I have to do is I need to rearrange the equation to get it in terms of K before I can work it out. So if I just jump straight to that, so I need to divide through by propanone times H+. So I end up with rate constant K equals rate divided by CH3COCH3 times H+. And then we can substitute our numbers in. So the rate is 1.24 times 10 to the negative 4 divided by the concentration of propanone, which you can see is 4.4, times the concentration of H+, which is 0.82. Now you will notice that we're given the concentration of iodine 5 times 10 to the negative 3, but we don't need to use that value because iodine does not appear in the rate equation, which suggests that it's order 0. So we can just ignore that. So let's work this out. And that value comes to, finally, is to determine the units for K. So what I'm going to use for that is, I do this in a different color so it stands out, is I need to use this rearranged form. And I need to substitute in the units for rate, which is moles per dm cubed, s to the minus 1. How do I know that? It tells me there. And then the units for concentration, which is moles per dm cubed. So we've got K equals moles dm minus 3 s minus 1 divided by moles per dm cubed times moles per dm cubed. So you'll see there's a moles per dm cubed on the top and the bottom, so I can cancel one of them out. So that can go with that. And then that leaves me with s to the minus 1 divided by moles dm minus 3. So finally, to get everything on the top on one line, I need to take the moles per dm cubed from the bottom on up to the top. So just to recap indices from maths, when something goes from the bottom to the top, you have to change the sign of the indice. So you have to remember that moles is 1 to the power of 1 and dm is the negative 3. So when they go to the top, that becomes s to the minus 1, moles to the minus 1, dm to the positive 3. In this next example, the first thing we have to do is actually work out the value of K before we determine the units. So it said the rate equation for the reaction between D and E is given below. So rate equals K, order 2 with respect to D and order 1 with respect to E. And then we're given the initial rate of reaction with corresponding concentrations for D and E. So the first thing I need to do is rearrange the equation so it's in terms of K. Then we substitute the numbers in. Comes to 0.001021, or in standard form. Right, so that's the value of K done. Next thing is to determine the units. What we need is the rearranged form here. And just like in the first example I did, I'm just going to substitute in the units for rate on the top, which is moles dm cubed s to the minus 1, which is there. And the units for concentration, which are always moles per dm cubed. So let's go ahead and do that, and we get something that looks like this. So 3 of them on the bottom because it's d squared. So now we can cancel out top and bottom. So 1 moles dm cubed with that one, and you can see we're left with s the minus 1 over moles per dm cubed times moles per dm cubed, which is going to be moles squared dm negative 6. Because dm to the minus 3 times dm to the minus 3 is dm to the minus 6. Remember, you have to add the indices. Finally then, to express on one line, what we can do is bring everything from the bottom to the top, and we must remember to change the sign of the indices. So this finishes as S to the minus 1 times moles to the minus 2 dm to the positive 6. And that's it.